Hi everyone, welcome to my session. I'm going to talk in this video about how to design septic tank. A septic tank may look like a simple structure, but designing it correctly requires a clear understanding of wastewater flow, treatment requirements, sludge accumulation, and site conditions. In this video, we will go through the basic steps for designing a septic tank and its associated soak pit. A properly designed septic tank should have at least 2 compartments and should be water sealed. As illustrated here, the first chamber generally occupies about 2/3 of the tank's length, while the second chamber occupies the remaining 1/3. The outlet then carries the effluent to a soak pit or another appropriate drainage system. Before moving into calculations, it is useful to understand what design really means. Engineering design is a problem-solving process. It is often iterative, and the objective is to find the most suitable solution within practical limits such as time, cost, tools, and available resources. Several factors determine the size of septic tank. More incoming wastewater means a larger tank. Hydraulic retention time affects both tank volume and treatment efficiency. Similarly, temperature influences treatment performance, while the dislodging interval affects the space required for accumulated solids. Peak flow duration also influences the design flow. For practical design, we therefore need to select appropriate values for these parameters. In this example, hydraulic retention time may range from 12 to 24 hours, dislodging intervals from 24 to 60 months, and peak flow periods of around 8 or 12 hours. Temperature is also considered in selecting the design assumptions. Now let us apply these principles to a simple example. Our task is to design a septic tank for wastewater generated by 50 people. We begin with the design assumptions. There are 50 users, and let's say each using 100 liters of water per day. Conversion factor 80%, and the temperature is 20 degrees Celsius. The dislodging period is 2 years. The hydraulic retention time is 24 hours, and the peak flow period is 12 hours. Let's calculate the daily wastewater volume, multiplying the number of users by the specific water consumption and the conversion factor. For 50 people, this gives a wastewater flow of 4 cubic meters per day. Next, we determine the peak flow by dividing daily wastewater volume by peak hour, which gives approximately 0.33 cubic meters per hour. We will use this flow to determine the required liquid volume. The liquid volume is calculated by multiplying peak flow and the hydraulic retention time. That is 0.33 cubic meters per hour, and 24 hours of retention gives liquid volume 8 cubic meters. We also need adequate space for sludge and scum accumulation till it is emptied. The calculation considers the number of users, the sizing factor, the accumulation rate, and the dislodging period. The sludge and scum accumulation rate is 25 liters per person per year for black water only, and 40 liters for both black water and grey water. Here, the volume of sludge and scum is 4 cubic meters, as we take sludge and scum accumulation rate, 40 liters per person per year. As this table shows, colder conditions and shorter dislodging intervals can require a higher sizing factor. For our selected conditions, the appropriate factor is applied to the sludge storage calculation. The sizing factor is selected for temperature 20 degrees Celsius or above, considering as the site of septic tank is hot in climate and dislodging period 2 years. We can now determine the total volume of septic tank, which is calculated adding liquid volume 8 cubic metrics and sludge and scum volume 4 cubic metrics. This gives a total volume of septic tank. The next step is to use this volume for dimensioning of septic tank. We take a liquid depth of 2 meters and a length to breadth ratio 2:1. From the calculation, the required breadth is about 1.73 meters, which we round to 1.75 meters for practical construction. Using this breadth, we can determine gross length of septic tank, which is 3.5 meters. Following the thumb rule of length of the chambers, that is 2/3 to 1/3. The first chamber is approximately 2.3 meters long and the second about 1.2 meters. The liquid depth remains 2 meters. Now let's design soak pit. Liquid coming out of the septic tank is managed safely using soak pit. A soak pit is simply a pit that is filled with stones, preferably over burnt bricks. These materials provide additional surface area where biological and chemical processes can take place. A soak pit, however, is not suitable everywhere. It should be located at a safe distance, both horizontally and vertically from water sources. It is not recommended for the areas with flood-prone and low permeability and high groundwater table. Soak pit sizing mainly depends on the volume of wastewater and the infiltration rate of soil. Here, wastewater flow remains 4 cubic meters per day. and we take an infiltration rate of 240 liters per square meter per day. The table illustrates how infiltration capacity varies considerably between different soil types. We determine the required surface area for infiltration by dividing the daily wastewater flow by the infiltration rate. This gives us an approximate required infiltration area of 16.7 square meters. Let's do sizing of soak pit using the surface area for infiltration. We assume a circular soak pit with a radius of 1 meter. Infiltration takes place from the sidewall and bottom of soak pit. Thus, using this formula, we calculate the depth of soak pit, which is approximately 2.15 meters. For practical construction, we take a depth of 2.2 meters. A septic tank is more than just a structure. It is a small treatment system that protects public health and environment. Good performance of septic tank begins with the right design, means the right size, adequate retention time, sufficient sludge storage. When these elements are properly considered, a simple septic system can provide reliable and sustainable sanitation. Thank you for watching, and remember, right design leads to safe sanitation and a healthier environment and public health.